Hello, everyone, and welcome to the Anti-Doping Podcast, brought to you by the Partnership for Clean Competition. I'm your host, Dr. Marie McNeely, and today, listeners, we are joined by our expert guest, Dr. Nicolas Leuenberger. Listeners, Nicolas conducts research for the Swiss Anti-Doping Lab and the University of Lausanne. His research has traditionally focused on blood doping, but he's also done expansive work on identifying biomarkers in dried blood spots. He joins us today to discuss his hematological research. So, Nicolas, we're excited to learn more about you and your work today. So thank you so much for joining us. How are you?
It's okay. Thank you very much. It's a pleasure to be here with you and with our audience. And in Switzerland, it's pretty cloudy, but normally in October it's very sunny.
Wonderful. Well, I'm glad to hear things are going well for you there, and we're excited to dive into our questions. So maybe can you start by just telling me and our listeners more about yourself and your background in research?
So I did my PhD more in genetics, in genomics background with a lot of molecular biology. And just after my PhD, I started in anti-doping laboratories. At the beginning, I focused on EPO analysis, but now I'm responsible for biology unit in the laboratory. And this is my first part in the laboratory. The second part is to deal with research and so teaching in university about anti-doping and about research. Directly, I focused on genetics and molecular biology with circulating microRNA at the beginning, and now I focus on RNA. And for me now, the key step is try to analyze all these biomarkers on dried blood.
Oh, phenomenal. So you mentioned that it was after your PhD that you started working for that anti-doping lab. What first piqued your interest in the area of anti-doping?
So it was a little bit by chance, but of course with my interest, because it was in 2002. I did a work placement in the laboratory during 2 months during my vacation, my university vacation. It was quite very interesting. And after my PhD, of course, I searched a job and I contacted Marcel Soji at this time. It was the former director of the laboratory, and now he's the Dr. Tiakuan. So Marcel was quite interesting to meet me because I did my PhD in quite important laboratories in Switzerland, in Lausanne. So it was a good background, and he wanted to meet me. And during the first meeting, he told me, yes, I need someone to deal with biology, and maybe you could be the guy. And for that, I started like this. And after 12 years, I'm always happy to come to work in this laboratory.
Phenomenal. I've heard from a lot of people that they end up in anti-doping sort of due to chance or sort of due to these unexpected opportunities that pop up. And I think that's awesome. In your research specifically, we mentioned you've done a lot of work related to blood doping. So what was it about blood doping that really drew your interest?
You know, I have a background of biology, than analytical chemistry, and also because I'm working in the laboratory of Lausanne, and the laboratory of Lausanne is very specialized in athlete biological passport for the meaning of the birth of this passport. And with background in biology and this background in the laboratory with the athlete biological passport, I think it was like evidence that it was for me the best way to do research. It was in blood doping with EPO, blood transfusion. So it was, yes, because my biology background, blood doping, it was the most interesting thing. And also because I interested about the endurance sport. It was the best way to go.
Definitely. So were you an endurance athlete yourself?
Sunday athlete. Of course, I perform sports, but not in a semi-professional license. Of course, I'm very amateur. I make everyday sport, but this is for me not to win medals.
That's awesome. So what is your favorite sporting activity or sporting event?
I did a lot of racing. I organized myself some race. I'm now 41 years old, so I have to make a sport to be still young. So this is like a mandatory stuff to do.
Oh, phenomenal. Well, let's get into some of the details of blood doping then. I know for our listeners out there who might not be as familiar with the details, blood doping is kind of an umbrella term. Several things can fall into the bucket of what an athlete can do to enhance their performance by increasing their red blood cell mass to transport more oxygen to their muscles to thus increase performance. So can you maybe briefly describe some of the methods of blood doping that are concerns today?
3 years ago, there was a big scandal in doping. It was a Dallas case, a Dallas report. And we observed at this moment that the method that was the most used in blood doping with athletes it was a blood transfusion, and no more common blood transfusion than micro transfusion. And we observed that with this famous now, unfortunately famous video with Max Hauke, that was this young athlete in this after Adalas report. And everyone has observed at this moment that they use no more transfusion with a lot of blood or five, but micro transfusion. And micro transfusion, I think, is more challenging than micro injection of EPO, of course. And this is for me a very big challenge to tackle actually to detect this.
Definitely. And for our listeners out there who don't know the term, autologous blood transfusion is injecting your own blood back in. So what are maybe some of the biggest hurdles for detecting this autologous blood transfusion?
So yeah, the autologous blood transfusion, because this is the whole blood from the athlete that is reinfused after storage. And the biggest hurdle for the detection is the sensitivity, because it's more about microtransfusion, as I explained. And the sensitivity is very complicated. And of course, because this is not exogenous substance, you re-inject your endogenous blood, and this is very difficult. But I think we have quite a good way to discover new biomarkers, very sensitive biomarkers, to try to detect that. And I'm also happy to participate to another project with other laboratories and with Copenhagen laboratories also. And we try to challenge that to tackle this problem with new biomarkers that we developed.
Very cool. And I'd like to touch on the topic of microtransfusion because you've mentioned it now a couple times. What sort of volumes are we talking about with microtransfusions as opposed to one large sort of bolus of incoming blood?
I think it's close to or it's less than 100 milliliters. So it is because we perform in Lausanne some clinical study with autologous blood transfusion, and we used to, and also in clinics, 500 milliliters of concentrate of erythrocytes, concentrate of red blood cells. But now the microtransfusion, which we speak about microtransfusion, is 5 times less, like 100 milliliters. So it's very, very few. The question is, when athletes make this microtransfusion, is there is a defect or not? And I think if you accumulate on this microtransfusion, you can have a defect, of course, on the performance.
Certainly. Well, I think you mentioned some challenges, the small amount of blood that is sort of repeatedly being injected that can make it difficult to detect. And of course, injecting your own blood makes it hard to identify because there's nothing really kind of foreign that you're injecting. So how do we overcome some of these hurdles in blood doping and in detecting blood doping?
I think it's continuing to work on new sensitive biomarkers. And we observe this time that some biomarkers that could be good is simply, or I can say simply, plasticizers that accumulate during the storage of this blood. But now I'm sure that the athletes can deal with that, also can reduce the storage so you can prevent the detection of the plasticizer that accumulate during the storage. So for me, the best things to overcome this is to find some biomarkers that are impacted with blood transfusion in a physiological manner. That means, for example, we observe that EPO, if you monitor EPO by itself, after transfusion, you decrease your EPO concentration. That could be one way. Of course, we proposed and we published a paper also with our transgenic biomarkers that react after blood transfusion. That means that when you make blood transfusion, you impair the erythropoiesis, and that means the EPO production and also everything that is linked to the erythropoiesis. That could be a way. The best way is to act as a longitudinal monitoring, as a direct substance or a direct test to detect autologous blood transfusion is very difficult.
Certainly, and I'm glad you mentioned this longitudinal monitoring. I know much of your work recently deals with this sort of intersection of dried blood spot testing, often called DBS, and the athlete biological passport, which involves this longitudinal monitoring. So can you talk about what value this DBS or dried blood spot testing can add to a program like the athlete biological passport?
Yeah, regarding longitudinal monitoring, you need a lot of samples to narrow down the detection window of doping substances, doping methods. So the value that is added with dried blood spot is easier than the standard blood collection. So you can athletes can do by themselves with video surveillance, for example. And with that, you can increase the testing samples, the number of testing samples. So that means if you had more testing points, you can, of course, be the better way to be the detection windows of a substance. So the value is you can increase a lot the collection time points with dry blood spot because it's so easy in terms of logistics. Collection, this is with finger prick or maybe with arm, with now some device that you can find. So this is the value you can increasing the collection sample.
Definitely. And you mentioned the fact that it's helpful, obviously, to have more data points to make it easier to identify some of these anomalies that you might see as a result of blood doping. So I guess how frequently are samples being collected now in the athlete biological passport? And maybe how often would you like to see them be collected to make it a little bit more effective or a little bit easier to identify these anomalies?
I think 1 per week could be nice for me because we observe, for example, for transfusion or EPO injection, that the peak of effect of this is 7 days or 1 week after the injection of EPO or the blood transfusion. The physiological effect that you can see with the best evidence is 1 week after. So I think if you take 1 blood per week during all the year, that could be nice.
Very interesting. Well, definitely something to work towards. And I think dried blood spots make it a little bit easier, as you mentioned, to do more frequent data collection. And I know you recently received funding from the Partnership for Clean Competition for a very interesting research project where you're developing methods for measuring hemoglobin using different matrices. So I'm curious, why did you focus on measuring hemoglobin for this project, perhaps as opposed to some of the other blood biomarkers under investigation?
Yes, because when you look for the active passport, there are mainly 2 biomarkers that we can focus on, which is reticulocytes and hemoglobin. So reticulocytes, we achieved to do that by looking for RNA from a reticulocyte. That means that we have something to mimic the reticulocyte induction after EPO injection, for example. So we did 1 step. The next step, it was the second main important parameter, was the hemoglobin. And we wanted to do that because our goal is to make an off score with dry blood spots. And this off score is done with hemoglobin and reticulocyte in the calculation to do this off score. And for this, we have the off score that can replace the reticulocyte with our RNA biomarkers. And we had a lack with hemoglobin, so for that we worked on this project to detect hemoglobin and dry blood spots to be able to make this off score. And we plan to make the publication in a few weeks, and we have a very nice results about this.
Very interesting. Well, we look forward to this publication coming out. And I know sort of calculating what's normal versus what's not normal, it's a big challenge with this athlete biological passport. So how do you address this, or how do some of these measures factor into this equation that you're putting together to try to identify cheating?
So we did exactly the same for the normal off score. We use the same method, and of course we compared with 3 different volunteers, 3 different patients after an injection of PPO, and we observed that we are more sensitive with our calculated off score with the dry blood spot and our biomarkers. So it's quite easy to do it to compare.
Fantastic. And I know in this specific project, you're comparing different matrices, as we mentioned, or sampling techniques, dried blood, and the process called volumetric absorptive microsampling, or VAM. So, Nicolas, can you describe the differences between each of these matrices, or maybe just a little bit of detail about how they are collected?
We wanted to test this to have a way to facilitate the volume of this collection, because this dried blood spot collected from the finger prick collection, sometimes it's difficult without pipetting the drop of blood on the top of your fingers to have the very exact volumes. And you need exact volumes to do hemoglobin measurement, because if you, for example, not 20 microliters of a drop of blood, but 25, of course, that can influence the hemoglobin concentration. And for that, we compare with volumetric microsampling once, because with this tool, we have the possibility to make dried blood spot collection with a finger prick method, and this volume could be controlled. This is a sponge that can collect only 20 microliters. And we use that and we compare it to control the volume. And that we are testing, so another sponge device that is a Tasso, And we observed pretty nice results with this. But of course, it's a bit better with the dried blood spot compared to worms, but we have still work on to measure it.
Now, a lot of our listeners out there might be familiar with these standard sort of traditional blood collection via tubes or even dried blood spots, but I think this volumetric absorptive microsampling technique is a little bit newer. So can you talk about, I guess, some of the benefits of using either these dried blood spots or the VAMS technique compared to the traditional tube sample collection methods?
One, I think, could be better due to the volumes, but dried blood spot is easier and cheaper. Then I think the benefit is, of course, that you have less volumes and the storage. I think the most beneficial effect is on the storage and the transport. So that is the main thing, that the logistics in general with these samples are very beneficial. And what we sometimes forget, now we use dried blood spot in our clinical study, in our research, and you observe that with this, that increase a lot the possibility of collaboration between the laboratory. Because normally we can exchange several samples if you want to exchange with different laboratories to compare or to make inter-laboratory assay. This is very complicated in terms of logistics, in terms of price to exchange samples. But with dried blood spot, we make exchange with Qatar, with Salt Lake City, with Paris, with all around the world. It was very easy because it is just in a normal mail, and that could help also not only in anti-doping, but also for the research in anti-doping for the collaboration.
Certainly. And you mentioned that this volumetric absorptive microsampling method addresses one of the issues by kind of controlling the amount of volume of blood that you get. Then for this type of sampling method, do you have to use like the temperature controlled storage while it's in transport, or how does this work logistically? I'm not as familiar.
Yeah, for the temperature also that facilitates everything, I think, in terms of logistics. So the temperature and so on. So I think that it's very, very beneficial to use this.
Gotcha. So the volumetric absorptive microsampling method, it sounds like, is similar to dried blood spots in terms of the benefits that you get for cost, ease of transport, things like that. Is that correct?
Exactly. Yeah, this is similar.
Wonderful. Well, thank you for kind of walking us through some of the similarities and differences of these different methods of sample collection, some of the benefits, the pros and cons of each. So in your opinion, what is the next big scientific leap forward then that you're expecting or maybe hoping to see for the athlete biological passport?
I think we have to start to test the ABP with dried blood spots to raise the sample collection. And one way to do that, and we started to do that, this is the easiest way to start, is to use EDTA samples, standard EDTA samples, and to make it to spike blood from EDTA samples to dried blood spot. And after that, we can compare with our biomarkers that we focus on with a standard biomarker that is measured with the Sysmex analysis, for example. And we have to start with this first test for the future, try to have an ABP with different biomarkers on dried blood spot.
Definitely. Yeah. I think comparing to the traditional method to make sure everybody can measure those biomarkers and measure them accurately and consistently is very important. I guess if we increase the amount of testing that's happening with these dried blood spots, do you think there will be a backup or then sort of downstream challenges in processing and analysis capabilities?
Of course, yes, we speak more and more about you need to perform analysis after because due to testimony of athletes and so on. So we have a lot of interrogation about how to store EDTA samples and how to store EDTA samples in time. So one way is to use dried blood spots.
Oh, very interesting. Well, you've obviously made a fantastic career for yourself in anti-doping, even though it was sort of an unexpected route that perhaps you didn't expect your career would take. But I guess for listeners out there who might be interested in anti-doping science, but not sure if they want to get involved, what advice would you have about getting started in this field?
So one advice is maybe focus on science and not on politics. Don't start anti-doping to start working anti-doping field with the will to save the sport from doping because otherwise I think you cannot manage all the stuff around anti-doping and doping. And if you focus on science you will be less frustrated.
Certainly. I think being passionate about the science is definitely important because, as you mentioned, there's some big challenges. There's a lot of nuance in anti-doping that you have to navigate. So being excited about the day-to-day science is definitely important. So if you had all of the resources available, Nicolas, and we took away a lot of the common pitfalls that you face in terms of funding, staff feasibility, and other logistical challenges, is there one problem in anti-doping that you would want to solve most?
As I told you, I think where we have to ameliorate is the frequency of collection of the samples. And if I have all the resources that can imagine, I would focus to start to work on chips that we can use with athletes, that we can observe already that in passion clinics, that real-time monitoring with a chip that say, okay, you can monitor anti-doping biomarkers, but also kill biomarkers. And of course, for anti-doping laboratory, that could be very nice for the monitoring, the personal monitoring, to see if in real time, if an athlete can be doped or not. And for honest athletes, not cheap athletes, that could be very also useful, like a real-time medical checkup. And this is, I think, maybe, I don't know, a little of science fiction, a little of future, but this is quite good to work on with a lot of money.
Oh, absolutely. I think this idea of being able to eventually have this real-time sort of constant monitoring is really attractive for anti-doping because, like you said, there are little windows and different windows for different substances and things that you're trying to detect, and it's hard to be able to capture everything. And I love this idea of also adding that element of being able to monitor health and wellness as well with the same technology.
This is for me the future, but of course, this is a little bit problem of ethics at the beginning, but actually we can do it.
Definitely. It's a big dream to be working towards and a lot of issues to work through on the way. But well, thank you for dreaming big with us on the show. Nicolas, we covered a lot of ground today. If our listeners are interested in your work and they'd like to learn more, what is the best way for them to do so?
I'm really happy to share interest about science and anti-doping and so on. So the best way is contact me directly with my mail. My mail, you can find my mail on some website in the publication, so don't hesitate to contact me if you have questions.
Fantastic. Well, listeners, definitely reach out, get in touch with Nicolas if you have any questions. Nicolas, it's been such a pleasure to have you on the show today. Thank you so much for your time.
Thank you very much, and thank you for the invitation. It's a pleasure.
Well, it's been great to chat with you. Listeners, wonderful, of course, to have you here as well. If you want to stay connected with the Partnership for Clean Competition, you can follow the PCC on Twitter at PCC Anti-Doping or visit the PCC website at cleancompetition.org. We hope you'll join us for the next episode of the Anti-Doping Podcast.